Good morning to one and all present here. Myself, Sai Gujral, on behalf of ABS Engineering College, I would like to welcome you all in today's session. And it's my pleasure to invite Dr. Surbhi Bhatia. She is doctorate in computer science and engineering from Banastali Vidyapeeth, India. Recently she earned project management professional certification from reputed Project Management Institute, USA. She is currently an assistant professor in Department of Information Systems, College of Computer Sciences and Information Technology, King Faisal University, Saudi Arabia. She has rich 9 years of teaching and academic experience. She is the editorial board member with Inter Science Publishers in the International Journal of Hybrid Intelligence and in SN Applied Sciences, Springer. She has published 7 national and international patents. Recently, she has been granted the Australian patent dataset discovery using data analytics using AI. She has published more than 30 papers in reputed journals and conferences in high indexing databases with impact factor more than 5. She she is recently she is currently serving as a guest editor of special issues in reputed journals of Springer Computer Materials and Internet of Things and in many international conferences. She has delivered talks as keynote speaker in IEEE conferences and in faculty development programs. She has successfully authored 2 books from Springer and Wiley. Currently, she is editing 3 books from CRC Press, Elsevier, and Springer. She has been selected in the prestigious Best Young National Award by IRDP Group of Journals in India. She has successfully been awarded the research project from Deanship of Scientific Research at King Faisal University and also from Deanship of Scientific Research at Princess Noah bint Abdul Rahman University with research grant. We are extremely happy to welcome you, ma'am. And now I over to you, ma'am.
Uh, Ma'am, sorry to interrupt you. Just there is correction. Actually, Sai has mentioned that recently she has guaranteed. Actually, Sai, that there is a correction that is not guaranteed, that is granted. Am I correct, ma'am?
Yeah, you're right.
So congratulations, ma'am, for your international patent grant,
Thank you very much.
and welcome to the session. Over to you, ma'am.
Thank you, Dr. Vikas, for giving me this opportunity to be a guest speaker in this FDP. And I'm really happy to be a resource person for this session. So let me share my screen. I hope you're giving me the rights. Yeah. I hope my screen is visible.
Yes, ma'am. Yes, ma'am.
Yes.
Okay. So the topic of presentation today is opinion mining in information retrieval. Let's have some insight on what is opinion mining and why it is actually important nowadays. So, due to the advancement of web and availability of internet, considerable attention has been given to the web documents as they serve as an innovative medium of representing individual experiences in the form of reviews, blogs, comments, feedbacks as consumer generated media. I'm sorry, but I think somebody has to mute their mics, please. There is a lot of disturbance. Excuse me, Dr. Amit. I think somebody has to mute their mic.
Okay, ma'am. Just I'm saying. Ma'am, you are audible well, I think.
It's okay, but I think there is a lot of disturbance of outside noise, something like that.
Okay, so I'm
Okay.
going to mute all and then you can unmute yourself only. Is it fine, ma'am?
Okay. Yeah, thank you.
Yeah. Now everybody is mute now. Ma'am, you can unmute yourself and you can continue.
Okay, thank you. Okay, so again, my screen is visible, right?
Screen is visible, ma'am, and audible too. No problem.
Okay, thank you. I'll go on then. So I was talking about the advancement of the web and the availability of the internet. So that basically means it has impacted web users who seek online reviews for making some kind of decisions on certain products of their interests because of this easy availability of online reviews. So the social media and review sites, these are the most impressive source of market intelligence. Why? Because they can be used by the people for directing some kind of market opportunities. And what are actually opinions? Opinions are nothing but they are referred to as subjective sentences which are reflecting some people's sentiments, perceptions on entities or events. So I believe with the increase in the demands in the social network analysis, daily opinions are being posted in huge. So this opinions actually earlier they were survey based, feedback based research. They were people tend to buy or sell products by posting some kind of advertisements. They used to conduct survey groups, focus groups, consultants, or they used to take opinions from their friends or relatives. But now they are not restricted to just some few circle of friends or family, but they actually have spread globally to our lives through social media. So this transition from surveys to now social media is actually very interesting. Therefore, I will be discussing in today's session how to extract opinions from the text and how the procedure called opinion mining is there. So, online shopping today, as discussed, online shopping and being online, they have become a trend nowadays on social media. So, opinions, the two main vital roles which are played by humans, they are sentiments and emotions. So, what is human feeling? Human feeling and emotions, they can be described as some entity, some event, or some properties which are actually evaluated using a subjective approach that can be called as opinions. This technique of some extracting some kind of knowledge automatically by taking these opinions from social media and other review sites such as Facebook, Twitter, web scrapper, etc., the blogs, etc., on a specific topic is called opinion mining. So humans have actually vital impacts on opinions as they help in the decision making process. And nowadays, internet have become a huge resource of blogs which are getting created daily, and millions and millions of posts are being posted daily, and so much Facebook and Instagram active users. So now we can directly say that earlier from feedback based research, it has been shifted globally to the blogs, posts, tweets, and social networking sites because these have become a trend and people are now addicted to it. So there is a lot of increase in the number of users on the internet. If we view the statistics of the year, which has been taken from some kind of consumer survey, we see that 84% of the people trust online reviews as much as a personal reference, and 74% of the consumers say that these positive reviews actually make them trust a local business more. So opinions of people are actually they are scattered on various sites. Though we have some kind of applications of innovative searching techniques and current searching engines, but they serve to extract documents as a web page with respect to some keywords, but does not give us summarized opinions with respect to the features. So this is what we'll be discussing in today's work. So the major areas under opinion mining as written, these are opinion retrieval, we have aspect identification, then sentiment analysis, and the opinion summarization. So these research activities actually focus on different areas under opinion mining. Though there are several techniques, but none has actually approached the issue to develop a coherent structure, or in broader terms, like a search engine or an information retrieval system, which would cover all these aspects under opinion mining. And there is very little attention to actually conceptualize this structure of mining these opinions. There are efforts on developing opinion mining system previously, but they had various limitations, which are written like parsing of HTML code of web pages for extracting relevant contents. This has been taken earlier, but there was no crawling mechanism. Then generally the nouns were considered as the target entities to extract the aspects. URLs, the most common application in aspect identification for target entities were basically nouns and their closest adjective. There were some kind of ontology based approaches also, but they had several limitations, which I'll be discussing in the presentation in future slides. There were traditional supervised learning approaches, unsupervised learning approaches for the classification. And for some opinion summarization, there were a lot of duplicate sentences, the redundant sentences, which were actually included in the summary, and how we can remove or prevent them. I'll be discussing that as well in the overall research. So coming to the year 2002, which actually indicates the beginning of this research, and 2012 has shown a remarkable growth in this field of opinion mining. So the current, this social networking sites, they have captured the market because of tremendous growth of opinions and feedbacks. And all these social networking sites like Facebook, Twitter, the other site Jabber, etc., they are too much in available, and people are actively using them on the World Wide Web because they provide good exposure to the web intelligence and the information retrieval systems. So current search engines, if we talk about the current search engine, they search for facts, right? Instead of just retrieving the document or the web pages, a person, if he wants to retrieve some opinions in summarized form, it is not available. So it is not applicable for the opinion retrieval search. So this overall session, I'll be discussing how we can develop an information retrieval system covering all the aspects which I discussed just now, like opinion retrieval, aspect identification, sentiment analysis, opinion summarization under opinion mining. Now, what are the general steps in opinion mining? So I believe that what I have just now explained you have given you an idea that this gaining attractiveness of Facebook, Twitter, other review sites on www, that is World Wide Web, they are majorly involved in providing good exposure to the web intelligence and information retrieval systems, right? So I believe there is an emergent explicit need which is there for the people, so that an overall IR system can be developed which helps us to analyze the opinions as positive reviews, negative reviews, and a concise summary considering all the aspects can be seen. So search should start or should encompass these various components, which would start posting a user query on some particular topic. Say, for example, the policy making during COVID-19, or some reviews on iPhone 11 Max Pro, etc. So we are going to crawl opinions related to that search query in order to categorize the opinion as positive, negative, and then fusing all these sentiments together to present the summarized opinion. So number one is opinion retrieval, as you can see here. So opinions can be collected from the various sites, webs, blogs, tweets, other social networking sites with the help of a web crawler. Second is opinion detection. Opinion detection basically focus on the four parameters, which are trust, polarity, opinion score, and quality. Coming to aspect identification, the task of opinion mining in order to extract the people's opinions on first features of an entity, it can be done on three levels: the document level, the sentence level, and the aspect level. So aspect detection means extracting the features out of the sentence. So you can say feature extraction. Next, coming to opinion classification, which means analyzing each opinionated word for determining its polarity orientation. And last, coming to opinion summarization, which means giving a concise view of the summary of the opinion. So it is, again, there are many techniques, but broadly we can define opinion summarization to fall under two categories. One is endogenous methods and the second is exogenous methods. So endogenous means the methods which are based on machine learning and training, and exogenous methods, they are some kind of, give us some kind of external source of knowledge, which is rather dictionary based. So coming to the next part, what is an opinion? Opinion textual information, I believe it's divided into two categories. So one is your text information, which you call is at facts, and second is opinion information, which are the opinions. What are facts? There is an example given in the slide, like the facts, these are the sentences which actually are true and they can be verified. But opinions, these are the sentences, they hold an element of belief and they cannot be verified for its truth. Yani you have some kind of opinion for that particular sentence, but the truth cannot be verified or validated. So human feelings and emotions, they are described, as told you earlier as well, they are described as entities, events, properties, which are evaluated using some kind of subjective approach. So the direct, regular direct opinion, I would say it has the basic four components, which are represented as number one, target, number two, sentiment value, number three, holder, and number four, time. Let me describe each of these four components one by one, giving you an example. So what is target? Target can be a single entity or it can be a combination of several entities. Coming to sentiment value, now these are the emotions, actually, emotions which reflect one's response in view of an entity type. What is a holder? Holder is a person who is holding some kind of opinion, and time would be a plan or an overall schedule of when opinion was posted. So coming to the definition of opinion mining, it's basically a procedure to mine opinions in very simple words. But it's a recent discipline which is lying as at the crossroads of information retrieval, text mining, and computational linguistics, which tries to actually detect opinions in natural language texts. So it's a field of natural knowledge discovery, and uses some kind of NLP technique, which you call as natural language processing, statistical machine learning techniques, to differentiate opinionated texts from factual texts, which I just described as opinions and facts. So coming to these tasks require techniques from the field of different NLP, IR, and text mining. So the main concern is actually to automatically identify these opinion components from unstructured reviews and summarize these opinions about an entity from large volume of unstructured texts. So the proposed work, which I'll be discussing now, it combines theories of different supervised learning techniques with the NLP tasks to complete the overall, to give you an overall information retrieval system idea, how it's built. So yani, the objectives would be opinion retriever. It must be built for crawling some kind of opinions from World Wide Web. Then we'll be discussing about how the aspects would be identified, coming to the classification, applying some kind of algorithms of deep learning, machine learning, classifications in order to validate the performance, and finally summarization for choosing some kind of relevant sentences from the text that would prevent the redundancy or the duplicacy of these sentences. So this would be the overall idea to discuss in this research. Now, let me discuss more about opinion mining. The opinion mining tasks. What is opinion mining task? The opinion mining tasks fall under three categories: the document level, sentence level, and the phrase level. So the document level, here the task is sentiment classification of reviews. The classes are generally categorized into positive, negative, and neutral. And we take the assumption generally that each document focuses on a single object. Coming to the sentence level, there can be two tasks. One task would be identifying subjective or opinionated sentences, and the other task would be sentiment classification of the sentences. So in task one, the classes would be categorized into objective and subjective. Subjective means opinionated. And in the task two, classes would be categorized as positive, negative, and neutral. And assumption can be taken as one sentence contains only one opinion. Coming to the third level, which is the phrase level or the feature level, here there can be three tasks: the identify and extract object features, then determine whether these opinions on the particular features in which you are interested or the user is interested are positive, negative, or neutral. And there can be task three, like we are grouping some kind of feature synonyms together. So these are the three tasks which I have described regarding opinion mining. What can be the applications of opinion mining? So opinion mining has various applications in different fields. It can be used in search engines, recommendation systems, email filtering, web ad filtering, or some kind of QA system, question answering system. And the list is on. So opinion mining application in daily life, it's most interesting as it can be used to improve human computer interactions, business intelligence, government intelligence, or some kind of citation analysis. So they're useful in many domains, like listed few, like search engines, QA systems, recommendation systems. And the applications are not just limited to these numbers, but there can be many applications where opinion mining can be used. So purchasing product or service, quality improvement in product or service. So manufacturers generally collect the critics' opinion in order to improve their quality. For marketing based research, so what are the recent trends of customers? It can be analyzed. For recommendation systems, classifying opinions for positive, negative system can say which one is review is good and which one is not. Detection of flame basically focuses on monitoring of news groups or forums, which can detect some kind of arrogant words. Then policy making, it can take the citizen's point of view in order to make some policy by the government decisions and towards some policy. So this is the overall applications which I have discussed in a list. Coming to the next one, the approach. So as discussed, opinion mining, it's a procedure to extract opinions from the text. So it's the field of the study which actually analyzes people's opinions, sentiments, evaluations, appraisals, attitudes towards entities. It can be the entities can be products, services, organizations, individuals, some topics, events, and their attributes. So this work is going to combine the theories as described, supervised learning theories with NLP tasks, and it's going to open new avenues for applied research in NLP, text mining, and within a few years, I think extensive research has been done in this area as well. So the overall aspects or the overall three tasks would be taken into consideration, as mentioned earlier as well, which are aspect identification, opinion classification, and opinion summarization. Let's discuss about this little framework, which is given as a name opinion score mining system. So keeping in mind the need of information retrieval system using opinion mining, a framework is overall proposed that is going to provide opinions to the user queries by providing some kind of opinions to be categorized and give us a summarized form of reviews. So it's an organized and unified structure for opinion mining, and the major part focuses on, as described, a user is going to post some query using a user interface, and some requests for opinions would be passing to the opinion retrieval, cleaning, and the pre-processing of data would be followed by tokenizing and using part of speech text using NLTK processing techniques. Further, it will be passed to the overall OSMS, which is opinion score mining system, in order to score the opinions. So it will be passed to opinion identification for identifying whether it has the particular website or the sentence has the opinion or not. Further, going down to opinion classification for categorizing into positive, negative, neutral reviews, and finally into opinion summarization to give a concise view of the as a summary to the opinions. Finally, the summarized opinion will be transferred back to the user by through a user interface. So the emphasis is, the overall emphasis is on describing the opinion system as a framework, and this system it will be defining the development of complete architecture, how to mine the opinions. So coming to the first one, which is opinion retrieval. Now, the task of opinion retrieval is, it's simple to extract the reviews from various sites and social networking sites. So there would be some kind of seed URLs which we can feed as the initial part for they can be obtained from various search engines in order to retrieve the opinions. And which search engine we are preferring? We are preferring Google is used. Why? Because it's a speed retrieval process and precision based text results. After pre-processing is done, the relevant tokens, after removing the stop words, features can be extracted, and the novel methods based on some kind of grammar dependency rules, I will be discussing them in the future slides. So for each review, the thematic word and its related opinion word would be extracted. Coming to the next part, which is opinion identification. The opinions would be identified to check whether the relevant content is there or not, even with the grammar dependency rules. Opinion classifications. In opinions would be classified according to the target entity into positive and negative category. So I'll be discussing the state of the art machine learning classifiers and some kind of deep learning algorithm like CNN, convolutional neural network, how it works in order to classify the text. The different the accuracy would be also compared with this method, deep learning algorithm, after modifying the parameters. So finally, the two summaries would be taken to explain how the concise view of the summary is created by abstractive and extractive approach. So what is abstractive? What is extractive? I will be discussing in detail. Generally, the abstractive based approach is based on the graphs methodology, and extractive is filtering the irrelevant sentences and picking the most relevant sentences out of a list using some kind of PCA technique, which is principal component analysis. Finally, the analysis would be done on the rogue using the rogue scores, which is a tool implemented in Java. What the data set I have used for this research is the proposed work. As I've discussed, it combines theories of supervised learning techniques with NLP tasks. So I have used the First data set as the multi-domain sentiment data set, which is again a public available, online available, and the type is text, and there are several product reviews from Amazon.com, which covers the products, the entities such as books, DVDs, and musical instruments. The second is the famous movie review data set, which is again a text-based data set, where a collection of movie reviews for various opinion analysis tasks is there. The third is the Opinosis tests, which is a data set given by by a famous researcher, Ganesan, in this opinion summarization task. And here, again, the type is of text, and topics related sentences which are extracted from different user reviews are there. So there are different topics, around 51 topics, and each topic have 100 sentences on an average. So again, the reviews which are obtained from these data sets are taken from multiple sources like TripAdvisor, Admin Scars, and Amazon. Apart from these data set, I have also extracted the data set using opinion crawler, which I'll be discussing, and I'll be analyzing my extracted data sets with these data sets which are online available. So as discussed, what are the primary components of the opinion score mining system? So it generally takes, as described earlier also, it generally takes the input from the user in form of queries and returns back the opinions from its resources in summarized opinion form. So the novel algorithm and techniques which are proposed, I'll be discussing all of them. So number one, opinion retrieval. The functionality, it's similar to a general crawler with a major difference that it is going to download just the opinions. Unlike the general crawler, which downloads all types of web pages whenever we post some kind of query. And since the opinions, they are posted, it gets updated at a greater frequency than these general web pages. So retrieval needs to recrawl these web pages more frequently to maintain the freshness in the repository. This is very important. So to calculate the dynamic priority of each URL is very important to extract the most recent reviews out of these seed URLs. So how it will be done, I'll be discussing in detail. Coming to the next part, where appropriate time interval between the two successive crawls of the web pages is also taken into consideration. So these are the prime components. Coming to the aspect identification and classification of opinions. After cleaning the opinions, the opinion repository, it contains the tokens with its application tags, and finally coming to the aspect-based opinion summarization. If you can see this overall framework design of an opinion score mining system, it would be more clear to you like how the query is passing through the surface, it's traveling to the opinion retrieval system, and there is a World Wide web pages are in the form of the opinions. The crawling mechanism is applied for crawling the opinions from opinion repository. Finally, the opinions are coming as pre-processed opinions, and the filtered opinions are stored in the repository known as filtered opinion repository. Coming to the opinion classification part, the identifying aspects, the thematic words with its opinionated word is very important in order to give the user aspect-based opinion summarization. So this opinion identification will be consulted by opinion classification as well as opinion summarization. So again, the aspects which are the opinion words in the form of opinion words, they are stored in the opinion word repository. Coming to opinion classification, there is a classify opinion module, which is going to classify the opinions and store it into a repository as classified opinion repository. Finally, the summarized opinions will be looking at the will be consulting the opinion word repository as well as classified opinion repository to check to give a summarized repository. So if the two sentences they have a potential to be fused, then only it is going to consult the classified opinions repository, right? And finally, the summarized opinions will be passed to the OSMS surface interface, and the user will be given a response of the query posted. So coming to the first module, that is opinion retriever. So if I discuss about the present work, which generally focuses on the algorithm and the techniques used in designing the opinion retriever, it generally works on an extended layer on existing search engine. So like Google downloads opinions from various sites, right? So it ignores the rest of the web. So the novel techniques in order to crawl these web pages, which is periodically updated in some order for extracting the opinions as mentioned before, also by computing some dynamic priority of each site. Why this is calculated? To make the repository refresh, to give you the current and the recent reviews all the time, right? So this the limitations of the previously developed extraction systems, they used basically wrapper model approach, so which mostly depends on the template, and it also increases some kind of maintenance cost of websites. Even the high complexity of the algorithm limits the ability for scalable extension of mining, and whatever developed so far do not evolve with time. So they again are limited in the scope and scenario, and they are there is a lack in improving quality of local collection, and sometimes give irrelevant content which may be not of interest of the user. So how actually the earlier limitations I'll be discussing in detail. The websites, they basically use the scripts to generate the highly structured HTML, which includes some kind of shopping sites, entertainment sites, academic repositories, library catalogs, and virtually any website that uses some kind of forms to fetch content from these databases. So the structured similarity of the script generated web pages, it's a powerful feature actually that allows some kind of information extraction systems to use simple rules for extracting information from these websites. So our method works on the HTML snippet of each web page, which is analyzed, and when it's viewed as an XML document tree, the XPath is the following XPath is will extract the opinions from the web page. So the rule says that opinions can be found under the span tag, under the review tag, text within which if you overall analyze the HTML page, then I'm talking about the review will be generally found under the span tag. There are tags, right? So span tag, where a review text would be there, and the review text would be generally in the div class or the p class. So this rule actually works on particular web page, and it works on any page generated by this form. So this is an effective mechanism for extracting information for a given website, and it can be learned also using a small number of labeled examples. So it's able to perform information extraction at each website with very high accuracy. So coming to the opinion retriever more, it just works by proposing some kind of novel algorithms and some kind of approaches, which I have just now discussed, how to extract the relevant and the fresh opinions. I'll be discussing that as well. So this overall opinion retriever consists of these 6 modules, which is 6 submodules, which is given as a URL fetcher, the tracker, downloader fetcher, repository, and the update. And wherein the update module is very, very important to understand. So this is the overall architecture. Let me explain you this architecture, how it's working. So URL database consists of the URLs, which are the seed URLs. And these URLs, they are generally stored in the form of a queue with the timestamp information associated with the URL. So these timestamp, it contains the average time difference of existing opinions and the new opinions. So the URL with the lowest timestamp will be given the highest probability that it is having some kind of new opinion, right? And the seed URLs, which we generally give to the URL fetcher, they are given the priority, the timestamp as 0 initially. So the URL fetcher, as you can see here, it's going to extract the seed URLs and send the URL avail signals to opinion tracker in order to fetch the URL from URL register. You can see there are signals which are getting passed, right? So the tracker is going to check if if the URL it contains the opinions or not. And then downloader is going to consult the World Wide Web for downloading and storing the bringing the particular document page, web page, and store it in the page repository. Further to it, the fetcher is going to analyze the overall structure, the mechanism that I just now described in previous slide of the HTML page, and using some kind of string matching techniques, it's going to fetch the exact opinion. So next, coming to the update module. Now, what this update does, this update is going to prioritize which URL to fetch by the URL fetcher by calculating the timestamp information, right? So this update module is going to further extract each URL which are stored individually in a file, and it's going to calculate the average timestamp of each URL and store them in some kind of URL database as mentioned as a repository with the timestamp information with that respective URL. So this update module, it is calculating the revisit frequency. When revisit, that means the URL one time is taken, it has the opinion, again it would be revisited if some fresh or recent post review opinion has been posted to that particular seed URL website. Okay, so revisit frequency, it can be computed by finding out the appropriate rate at which the retriever will going to revisit this URL again. So opinions of these URLs are getting updated more often, and it will make the revisit rate of that URL to increase. So, however, this may not always be true, as frequent updating of opinions, it may not provide that updated information. So the updating rate of the page, it needs to be modified by calculating the average timestamp of each individual URL, and the average timestamp of each URL, how it is calculated. It is calculated separately to make the retrieval basically efficient and updated. So this is the formula which is given. As you can see here, it's the appropriate time interval. Delta T is equal to D opinion date minus D new opinion minus D previous opinion plus the time. And this average is denoted by the delta T divided by N minus I. So it's the appropriate time interval between two successive crawls and the web pages. So this delta average would be giving us this thing, right? Coming to the next, how I checked the performance metrics of the same. So what is performance metrics? These are just the evaluation criteria, right? So the three basic performance metrics in the information retrieval metrics measures are taken, which are precision, recall, and F measure. So precision is generally the ratio of correctly retrieved opinions over all the opinions retrieved, right? And what is recall? Recall is the ratio of correctly retrieved opinion by the proposed system over all the opinions which are given by the experts. So the formulas are given and they are generally expressed as a percentage. F measure is the harmonic mean actually between the precision and the recall, and they are equally weighted. So the results, you can see the seed URLs. The queries are generally taken from iPhone domain, iPhone 7 or 11, from the seed URLs as Amazon, Flipkart, Yelp Me, and a total of 200 pages have been gathered. So crawling by crawler, and the result is 1,797 opinions, which are containing 3,000, almost more than 3,000 sentences. So even the comparison is illustrated here in the slide, which is giving what the proposed formula did, and it has the incremental feature. The recall precision are good, and it does not use any ranking of opinions. Coming to the pre-processing tasks, after the opinions are found out, so the cleaning of opinions, pre-processing tasks basically means cleaning of opinions which are accomplished using NLP techniques. So what are the tasks? The number one is removal of special symbols. So they are clean. The opinions are clean using regular expression symbols, and they are removed since the reviews are natural text and full of unnecessary characters, right, and abnormal symbols. So we need to remove that. Coming to the second task, which is stop word elimination, and again, it is a commonly or rarely occurring word, so some kind of language specific functional words need to be removed. Next, coming to lemmatization. So dictionary form of word is retrieved by making use of some vocabulary. And I believe everybody knows the difference between lemmatization and stemming. It's having a very thin line difference. So lemma text, they for a given words allow a change form of word so that all the words, they can be treated as a single item for extraction reasons, right? So it removes the endings of the word and returns them to the base or the dictionary form of a word. Then coming to the tokenizations, we are going to split into tokens, categorize the English grammar in nouns, adjectives, and verbs. So this is achieved. So all these tasks are discussed as pre-processing tasks. Coming to the model of the pre-processing, so the standard core NLP version, which is having 34 annotators, are used to split the sentences, allow working at a sentence level. As I discussed previously, the three levels in opinion mining tasks: the document, sentence, and the feature level. So right now it's done at the sentence level, and extracting all the opinions is done. Finally passed to the SSL. SSL is nothing but stop word lemmatization and stemming. Okay. Finally, the cleaned opinion repository, it is formed, and tokenization is further done and stored the tokenized word using some kind of pause tag XML document as an output file. So the coming to the next module, which is aspect based opinion mining. What is aspect? Aspect is nothing but the features. So in general, I believe not all people like or dislike, right, all aspects of a product. So it differs from individuals to individuals. Now this majorly focus on three parts: aspect identification, opinion classification, and opinion summarization. So again, the data set, of course, it's prepared using NLP techniques, and the opinion words are found out, further mapping them to the product aspects. So the input text is taken, pre-processing is done, the thematic words and the related opinion words are extracted. So a thematic opinion word pair is formed. Finally, classification is done, and the summarization is done, and the output is given. So this is how it's working. So if I talk about the aspects based opinion mining, before that I want to discuss some models which are used for these aspects. So several models are created actually that can be applied to domain independent data set. And the most commonly used mathematical model, they are based on some kind of supervised learning techniques like HMM, CRF, or the latent diacritic analysis, that is LDA. So from a review of 1,000 sentences, it is actually difficult for potential customer to read reviews of all the aspects, right, at a time, and then make a decision whether to buy or not. So many research works, they have overcome this difficulty, and most of these earlier works were limited to some kind of frequency based models or relation based models. In frequency based, they identify frequent aspects of the products. How? By setting some kind of threshold value, and it extracts all the noun phrases, keeps these whose frequency is greater than some kind of threshold value. And the relation-based model, it finds the relationships between words and sentiments by using some kind of opinion lexicon, which is a senti-word net or Vader score. Usually engages the pause, which is the part of the speech patterns for extracting aspects. Now, what is actually an aspect? Let me give you an insight on what is an aspect. So, aspect is nothing but it's object or a part of object or attribute, thematic word or target entity, which is aspect. And the opinion words like adjectives or adverb is related to the opinion word. So thematic word is a term about which review is expressed. Okay, so it represents the main theme of the document, right? And both this target entity and opinion words, they are closely related to the opinion. Okay, so the target is just to identify opinion targets, and mapping we done to opinion bearing words. Even the example is given, like this is a nice restaurant, so it identifies restaurant as a thematic word, and nice, which is an opinion word. So how the aspect identification is generally done. So as discussed, there are two main approaches for this particular word. So supervised approach is least favored because of its challenges in obtaining some kind of ground truth data to evaluate the performance of new algorithms. And if I talk, then the most popular unsupervised approach, it extracts the aspects that are found to be frequent noun or some kind of noun phrases. But actually, if you talk practically, then all frequent nouns are not aspects, right? So how this example is shown, existing word, basically they have shown that unsupervised dependency relation based approaches, they actually outperform both supervised noun and both frequent noun and supervised approaches. Why? This is because the infrequent aspect, they filtered out by some kind of dependency relation rules. So dependency based methods for extracting these aspects by means of some kind of semantic relation between a pair of words in a sentence is used. So once a specific relation between the words is identified, then aspect extraction can be done by involving these words. So the some kind of I have used informed selection of dependency relations here, some kind of heuristic rules, so that I can avoid the spurious aspect extraction, right? So the aim of this work is to give you an insight on by using a novel unsupervised method, which is combining the theories of rational awareness with sentence dependency trees for identifying the aspect. The example you can see here, Canon is not a genuine noun here, right? So Canon is not a genuine noun. Okay, so Canon camera product review. So Canon is not a genuine noun, but camera, yes, it's a noun. So therefore, we are interested more about camera, not a Canon, because Canon would be an camera would be an opinion word, correct? So dependency relation rules, they are able to determine the semantic relationships between the words. So for aspect expression, which is a problem of opinion mining, we take dependency parsing, pre-processing, lemmatization, post-tagging, which I've discussed of these natural texts, to obtain some kind of syntactic structure of sentences by the nouns by means of dependency relation rule. So I have employed Stanford dependency relations, which are there available, and NLP as linguistic features, and then present an aspect-based opinion extraction algorithm from these reviews. So I basically focused on the study of aspect extraction at sentence level, as told earlier also, using different NLP techniques. Now, it's very important that actually how these rules are chosen. This is very important. So how these rules are chosen, because if you choose the wrong rules, then irrelevant rules are going to give you wrong aspects, right? So that is very important. So this table is actually summarizing the list of dependency relations which I have used. As you can see here, adjectival complement, then there is an adjectival modifier. The abbreviations are given with the type dependency rules which are taken. So the dependency trees, they are created using Stanford parser. And what are dependency relations? Dependency relations, they relate one word to the another word in the same sentence, right? But each dependency relation, it has a head word and a modifier also that is going to modify the head word, right? So head word is going to determine syntactic type of phrase, and modifier, which is an optional, it can be removed without affecting any grammar of the sentences. So I run basically Stanford dependency relations to find the syntactic parsers. and it's going to map the dependencies between all the words in a sentence in the form of some relation like governor and a dependent, you can say. So again, Stanford core NLP parser is generally used in it's used in my technique to generate the dependencies of the running text, and parser it takes is taken in a review sentence and it produces a kind of a list of word pairs for each dependency relation like shown here. So the iPhone has a good screen, how it is related, it is shown. Now, the very important, as I told you, what rules to choose is again an important part. So it's given here, the sound of the speaker is clear, and so the output of the head and the modifier is clear and sound. So this is a nice camera to have. How the rules are actually working by using dependency, Stanford dependency tree. So we get the output as a head modifier as camera and nice, just now explained you. So apart from this, I also want to discuss that each dependency relation, it relates the word with different pause patterns, right? As you can see here. So if how I actually evaluated this, the experimental results again are used for some kind of validations. So to validate the relevance of dependency relations, I have used some data sets which are given here, and the MDS, which is a multi-domain data set, is used, which is having the product reviews of several products of electronic domain like digital cameras, cell phones, MP3 player, and a DVD player. So how many opinions are there, how many sentences were there, how many aspects we calculated, it's everything is given in this slide. So you can see here that these all were written as unstructured texts and text files, which were total of number of 852 writers, this MDS data set, right? So experimental results can be seen. I compared my results from two baseline methods. One is frequency based methods that I described, and second is double propagation method. So double propagation method is what? It's syntax based patterns. So to capture some kind of opinion relations in sentences. So DP extracts the opinion targets basically. So this extraction approach is evaluated as mentioned using customer reviews, and based on the empirical results, the proposed dependency patterns, it provide a moderate increase in accuracy of the results from these two baseline methods. So why I consider propagation method? Because sentiment words, they are considered to be adjective and aspects are considered as nouns or noun phrases, right? So the major key idea with known sentiment or more aspects, they can be found, and vice versa. So it does not scale well with large data sets. During propagation, some kind of adjectives which are not opinionated are extracted as opinion words. So therefore, I try to extract the aspects plus nouns. Okay. So it is seen here, if it is less aspects means low recall, and if it is more correct aspect, then it means high recall. Similarly, if there are more errors, it means low precision, and more accurate results will give us high precision. So this is overall about aspect based how the aspects are extracted. Now coming to the next part, which is opinion classification. Now this opinion classification, it's a vast domain and it's considered as sentiment analysis also. So coming to this part, measuring the sentiment in public in real time, it's always a difficult task, right? So previously, people tend to conduct a large amount of survey from different people, as told you earlier as well, to know about attitude of product. But this was not fruitful. So machine learning classifiers came into being, and majority of research in determining the sentiments today, they have been focusing on different machine learning classifiers and classifying these texts to make the task of classification much easier. So classification involves segregating of opinions into classes and classifying the text as inputs and outputs. So machine learning classifiers like naive Bayes, support Victor machine, maximum entropy, decision trees, random forest, they are either rule based or corpus based. So accuracy of these systems basically depends on how features are chosen, and then appropriate pre-processing tasks are applied, which actually make the system reliable. So how these features need to be extracted, they either need to be manually handcrafted, as well as they differ from domain to domain and from document to document, which actually makes them less generic and more text specific. So through these traditional classifiers, although they have shown good performance accuracy, and they have proved useful in sentiment analysis, but still they have certain drawbacks. Therefore, I will be proposing the deep learning algorithm, which I have used in this research to overcome these challenges as described. So deep learning, if I talk about the disadvantages of traditional machine learning classifiers first, so the machine learning classifiers, they use the traditional classification approach, and they require some kind of handcrafting of the features, right? So the number of layers of computations are also limited. They work well with unsupervised learning as well as supervised learning, but there are problems. There are several limitations, like problems of vanishing error. The neurons are not parsed, and although NN recursively diminishes the error. So coming to the deep learning, the strength of deep learning actually, there is no demand for carefully optimizing the handcrafted features. So instead of these features, we can take word embeddings as input, which contains the context information, and then immediate layers of neural networks. It can learn the features during this training phase. So it kind of allow very good representation learning. So while feature representation input that can be learned automatically from the training data for some kind of particular tasks. So these representation of words, they contains the context information, and it can be learned in an unsupervised manner. So deep learning, it's a branch of machine learning only, which contains a set of algorithms, and they attempt to model high level abstractions in the data by using different model architectures. And as mentioned, it learns good representations, how just now described you. There are many advantages and disadvantages. There are many advantages of deep learning algorithms, like they focus uh, uh, just now described that they learn good representations, and even there is no demand for carefully optimizing the handcrafted features. Now, among the deep learning algorithms I choose, there may be many algorithms in use in deep learning. So the base algorithm of deep learning, which I have used in this research, is convolutional neural networks, the CNN. What is the CNN? How does it work? Let me explain you. I've already discussed the advantages of deep learning. So what is CNN now? The convolutional neural networks, it has the many advantages, like it is actually treated as a type of feed forward neural networks only, and these are inspired by the organization of the animal visual cortex, which is general definition of convolutional neural network. So this the unified CNN, which is an architecture which was proposed by Colobert researchers, scientists. And the advantages of CNN, that it focus on a local area, it has different number of filter sizes, which are used for achieving some kind of optimization, and it also helps to identify the best local feature. So how CNN works, what are the layers, let me discuss that now. So CNN architecture is basically built on three main layers. So one is your convolutional layer, then is your pooling layer, and then is your softmax layer, the fully connected layer, where a softmax function is used. So we generally give the input and the convolutional layer, activation is done, and goes to the pooling layer. Some kind of dropout feature is implemented, activation function is applied, and the output is received. So this CNN basically helps us to classify. Here it will be used to classify the text into positive, negative, and neutral. So we are going to load some kind of positive and negative sentences from the raw data files, going to perform the cleaning of data as discussed, the pre-processing of the data. Then we are going to pad each sentence to maximum sentence length, and apply some kind of pad tokens to the sentences so that all are in the same length. Okay, we don't want different lengths. And why they are used to normalize the text basically, so that they can be fed into the deep learning model. And finally, we are going to build a vector from the text using word to vector embedding. So let me discuss the steps how to construct it. So the inputs are taken in with explicitly mentioned aspect, and output is the classified opinions, right? So CNN, as described earlier also, the core of the CNN, it consists of set of learnable kernels which are convolved basically across the width and height of input features, which is producing a 2D activation map of a kernel as described here. And what is a kernel? Kernel consists of layer of connection weights with the inputs being some size of small 2D patches, and outputs they can be bring about to a single unit. So whether or not kernel is convolved through all positions, it is determined by a stride factor. That is a stride. So here in pooling, non-linear downsamplings is used, where several non-linear functions are used to implement the pooling, such as minimum min pooling, maximum pooling, or average pooling. I use max pooling with the, and there is an example of 2 into 2 patches with a stride size of 2. Okay, so 2 means the two rows and 2 columns. Okay, so it works by partitioning the image. This is an image of the data into a set of non-overlapping rectangles, and for each subregions, outputs is given as the maximum value. So you can see here from one stride of 2, 3 has evolved. From the second stride, 9 has evolved. Next, the maximum value 7 has evolved. Why? Because I'm using the max pooling. From 0, 1, 3, 4, the last block, 4 has evolved, right? So what are the advantages? It reduces basically the computation for the upper layers. There are several layers, right? So it reduces the computations for the upper layers by removing the non-maximum value. And it provides some kind of translation invariance to provide the additional robustness to the positions, which are being a way of reducing the dimensionality of the intermediate representations. Now coming to the algorithm, the steps, how it's constructed, you can see here, the vector is built from a text using word to vec embedding. You can see the algorithm. Then a sentence of length n is represented in the form of n1 concatenation operator and so on. So this ni, it refers to the concatenation of words only, right? After that convolutional operation, it involves a filter w. It involves a filter w, which is applied as a window of k words. You can see here w and k. Okay, so I'm just giving you what does it mean, and it is used to producing to produce a new feature. Finally, the feature ci, you can see, I hope. So this c is generated from the window of the words, and this filter is then applied to each possible window of words in the sentence. Why? To produce a feature map. So after that, the max pooling operation, the max pooling over the feature map is applied, and it takes the maximum value as the feature which is corresponding to that particular feature. So what is the idea? Idea is to capture the most important feature, the highest value for each feature map. So once this feature is extracted from each filter, then multiple filters of different lengths can be applied to check on which is the optimized one, right? And these features, they form the p-multilate layer also, and they are passed to fully connected layer whose output is a probability distribution as the labels, which is classifying the text as positive and negative. So this is the flow diagram, which you can see the input is taken and it's converted to the vector, which is done by word to vec embedding. Also, I have embedded into it the CentiWordNet score, which is coming from the lexical resource as CentiWordNet dictionary. The univariate vector is constructed by these two scores, the vectors. Okay, and then the sentence shortening is done. Why it is done? To make the length normalized. Finally, the dropout of 0.5 is applied for training the CNN, and the softmax classifier is applied for classifying the output as positive, negative, and neutral. So how the construction of vector is done is very important in my research. So univariate vector I constructed by concatenating the two values. As you can see, first is the word to vec embedding, and second is the centi-word net score. So embedding what to vec is generally if it is 11th word sentence like do not buy this piece of junk. So I'm going to pad to make it normalized, and finally 11 into 300, which is an embedding matrix, is concatenated to 11 into 1, and finally a semantically rich vector is obtained for giving us a better results for classification. So this is how it's constructed. I have already explained you the coordinate structure, how the convolution is done, what function, activation function. There are several activation functions like ReLU, tan H function, the sigmoid function which can be applied. So I use tan H function for my, and even I try to optimize it, the work by seeing what effect it comes with the other functions as well. So I use 128 feature maps for each region size, and finally the max pooling. After max pooling is applied, the univariate vectors is constructed to form the single feature vector for the final softmax function to be applied to give the probability distribution as class labels into positive and negative. So the parameters which are used in my work is the data set I have experimented is with movie review data set. As you can see here, there are two classes: the sentence length, what is the data size, and what are the number of filters I use, filter size, how many epochs, iterations is went to, and activation function and the dropout. So the classifiers I tried with the softmax classifier, logistic regression, and SVM, but with the softmax classifier only the results were coming the best. So the results were coming the most better results were coming with softmax classifier on 256 feature region size and number of filters with 3, 4, and 5. So this is generally done for fine tuning, and basically to these fine tuning does not always fine tune models towards semantic similarity, right? So if fine tunes a word vector to make it work better for some given task, then this gradient will make word vector go closer to the other vectors. So that would again co-occur with some similar examples in the data. So like I give you example, happiness is close to loneliness. So it's clearly a mistake, but these two words seem to be together more in the positive reviews of movies, right? So I can see here that 85% for binary classification task is very low in modern standards, but property of the data set itself, it can be explained. So data was collected as many complete reviews that are classified. So coming to the last portion of my research, which is aspect based opinion summarization. So as told you earlier, so aspect based opinion summarization, which is the third task of opinion mining, and it is performed in such a manner where text is reduced in the shortest way possible without without losing some kind of important properties. So summaries, they may be produced from single document or multiple documents, and it should preserve important information, and it should be always short, right? So this is what the idea behind summarization is. So document, it can be the sentence is extracted, selected, ordered, and finally a short and precise summary is given to the user. So coming to the text summarization approaches, there are several approaches which you can see here based on the surface level features like title, keywords, words, they derive weights on key terms, etc. So number one is extraction, graph based, abstractive based approaches, combined approaches, and general techniques. So and these are the several summarization techniques. The combined methods, they have been proposed in my research. So one method that is containing two steps. One is separation of the phrases, removal of stop words, statistical methods, linguistic analysis, scoring of sentences, and finally extraction of the key phrases. So coming to the proposed work, I used the two types of summarization techniques. One is extractive based summarization and second is abstractive based summarization. So what is extractive summarization? Extractive summarization, uh, it involves combining the extracts taken from the corpus document into summary. So how it helps the user? It helps the user by extracting the most important pieces of information from a large corpus. So summary is made by selecting the representative text segments, usually which are sentences from the original documents, right? So how it works, I'll be discussing. Which technique I have used in extractive based summarization, I will be discussing in detail. The second is abstractive summarization. This abstractive summarization, they do not use existing sentences from input data. It analyzes the whole documents and it generally generates the sentences. So it involves generating more cohesive summary, and which may not present in the original information. Like you can see, the mouth-watering food is served, and second sentence is staff serves good food in hotel. So how the summary is generated, you can see here, the combining all the words. So I am focusing on aspect based opinion summarization, therefore 3 steps needs to be considered. What are those 3 steps? First is the feature identification, second is the sentiment prediction, and third is the summary generation. So you can see the flow diagram of opinion summarization with respect to abstractive technique and extractive technique. In abstractive technique, the input is taken, the token graph is built, it ensures correct the sentence correctness, and then the parts are scored by calculating the redundancy by fusing the sentiments, called opinion classification, and ranking the reviews. In extractive summary, I am getting the aspects from the sentences which are in the form of tokens, and I'm scoring those sentences by using sentiment nuts dictionary, by creating the matrix, finally applying the principal component analysis to reduce the dimensions of the matrix, and the reviews are scored by applying some kind of threshold value in the summary. So the first is abstractive based summarization. Here the steps are, I have already discussed in the flow diagram. The graphs are constructed, the accuracy of the sentence are ensured. So again, for ensuring this accuracy, I have used some kind of pause constraints. So the sentence contain noun followed by verb and adjective. Again, adjective followed by noun and verb. Then verb followed by adjective and noun. Adverb followed by adjective and noun. And last is adverb following the noun. So the start node should, how it works. Number one, let me discuss the steps. The graph data structure, which is opinion graph, opinosis graph, is used to represent the NLP tasks. The directed graph is used, which stores the graph information, like every word is treated as a node, and then position of the word is taken in a sentence, and edges represent the adjacency of the words in the pause tag of a node in a sentence. And finally, position of sentences in each document is found out. Then the accuracy of the sentences are checked by these rules. The start node should always contain a word which has average positive value in all the sentences lower than the threshold. And end node should not be a conjunction like but, yet, in order, etc. Then the scoring sentences and merging sentiments. So the paths are scored based on redundancy of overlapping the sentences, and then redundancy is calculated using some kind of intersection of these part of speech of words and sentences, such the difference between their position is no greater than the threshold value. And then node is considered, which is to fuse sentences. If it is a part of speech, it's a verb. So first we need to sentiment is looked upon, and then connector is chosen from some pre-existing list. So if both are positive, then use but, else we can use and or, right? So last, once the scoring is done, parts are fused, then ranking is done. Ranking is done in order to remove some kind of duplicate sentences using the similarity measure, and I have used the Jacquard index for calculating the similarity. Second, coming to the method described as extractive-based summarization. So in extractive-based summarization, the inputs, again, opinions are given with explicitly mentioned aspect. We consult the aspect, if you remember the block diagram, the framework architecture, which I shown you in the previous slides. So in the extractive-based summarization, the aspect repository is consulted, right? So here the step one is to score the individual words using CentiWordNet. So every thematic word, it's scored from CentiWordNet score, and then a matrix is created. So each matrix will be associated with some kind of reviews, and then the PCA would be implemented by applying the singular value decomposition function to the matrix, and the eigenvalues will be coming as an output from this. So after sorting these values of the cosine similarity in descending order, we are going to pick the most relevant sentences based on the threshold. So coming to the experimental setup, this work is describing an approach on directed graphs that use some kind of original sentence word to generate some kind of abstractive summaries. So I used the Rogue tool for evaluating the summaries. Rogue is a method. It's a tool basically which is implemented in Java, which means recall oriented of a GIST evaluation, using GIST evaluation. And again, the summary evaluation is done by using n-gram co-occurrence statistics. So it can be of three types: unigram, bigram, or trigram. So Rogue 1 and Rogue 2 are used. One refers to overlap of unigrams between this system generated summary and gold summary. So system generated summary are peer summaries, and gold summaries are human generated summaries, which is done by some kind of experts. So this is the formula which is given. Again, in the results, I have taken the results with data set 1 and 2. So data set 1 is the Opinosis data set, which I mentioned previously in the slides, which shows the researches for the data sets used. And second is the data set which I have extracted using the crawler. So you can see that high values of recall in extractive is seen than abstractive. Why? Because of criteria of selecting sentences in summary results in giving the higher values for this recall and lower values for this precision. So you can see in this diagram also the results for abstractive summarization. And again, the precision recall is used. Precision is how much of the system summaries were in fact relevant. So it's a ratio of recovered words that are appropriate to some search, right? And what is recall? Recall is how much of the reference summary is the system summary covering the relevant words. So it's the ratio of the words that are appropriate to that which is successfully recovered, right? So again, Rogue tool, as I mentioned, it's a Java package for evaluation of summarization tasks, which is built on the Perl script. And it consists of the set of matrix for evaluating some kind of automatic summarization of the text as a machine translation. So these are my results, which I have shown you for the system generated summary as the candidate summary, as peer summary, and the human generated summary as the reference summary, which is calculated using Rogue tool. So these are some of the sample summaries which you can see from the Opinosis data set about food and service for the query food. So the human summaries was there, extractive summary, how the abstractive summary is generated, and how the extractive. You can see in extractive summary, we have a list of sentences. From where these list of sentences came? These list of sentences came by selecting the threshold values to remove the irrelevant sentences and come up with the most used, most relevant sentences by using PCA, principal components analysis. And you can see abstractive summary is giving you much precise results because of fusion of the sentences is done and duplicacy of the sentences is removed using the rules which I have just now described in previous slides. So I have overall discussed the information retrieval system, which is focused on 3 tasks, as I discussed, which how to extract the opinions from social media, how to perform pre-processing of the tasks, Then it's also focused on different modules like how to extract the aspects, how to classify the opinions. Then again, aspect identification, it used rule-based approach to how to find the syntactical dependency relations. I also discussed about the opinion classification, used algorithms of deep learning, how CNN works, what are the layers in CNN, and how it actually works to give us the classified labels coming as a probability distribution into positive and negative. So finally, I discussed about the summarization by explaining you the two different types of summarization presented in this research, which is abstractive based summarization and extractive based summarization. So coming to the future work, big data, it opens up huge scope for opinion mining and sentiment analysis. And big data, it can give an opportunity to look upon huge volumes of data. I believe incorporating some changes in the rules of the grammar, and which it can be made compatible to other languages as well, like Hindi, Arabic, French, and so on. So some kind of removal techniques for this kind of text can also make the system more durable and more robust. Also, apart from CNN, I have just described CNN, you can apply some kind of deep learning algorithms like autoencoders, RNN, which work better with text. I use for CNN, but CNN actually works better with images, right? So some other algorithms of deep learning can be applied on it, and there are many applications for this in the area of education and training. There can be use of M learning, which is becoming inevitable and efficient in reaching its objectives. And also it can be commercially used if it is made an overall information retrieval system. It can be commercially used in selling the advertisements, and political issues could be mined for some kind of valuable information. So even any questions you can ask. This is a book which is available on online from Springer. This is my authored book on sentiment analysis. You can, if you want to get more insight into how the system works, what is opinion mining, what is sentiment analysis, you can of course refer to this ebook, which is available online, and it's published in February into 2020 by Springer Briefs in Computational Intelligence series. So any questions you have, you may ask me, please.
I request all the participants, you may write your question too if.
Yes, of course. My email ID is sbhatia@kfu.edu.sa. If you have any questions related to this session, you can of course write me, and you can ping me anytime on my email. I'm available. I will be glad to give a response to your queries.
Ma'am, more than a question, I have a curiosity regarding as it's my responsibility to ask actually the people from electrical and suppose electronics domain. So as I can see and from the presentation, it was quite well, and that the whole scenario is going on in like internet shopping or social media. It's going towards the computer industry, like. So what will
Right.
be the role of the people they have coming from the electronics or electrical domain? Can you give me some idea regarding this, ma'am?
I think this sentiment analysis and social media analytics, it's not just domain of the computer science. If you see about the social media analytics, right? So it's much focusing on the different marketing strategies, even in the electronics. If the last word which I used as it's opening up many areas on the big data. The big data is coming and evaluating, and it's opening many areas. If you develop an overall app or information retrieval system, you can definitely use as a commercialized application for your resources, right? So this social media analytics, it's a very broad domain, and many applications can be focused from several domains of electronics, computer science, and even. But yes, of course, coming to the core technical part, it focuses, if you are from a computer science background, then of course it would be more beneficial to apply some kind of computational algorithms, machine learning algorithms into it, right? But social media analytics, again, it's a hub of the things in which many applications and many techniques can be employed.
Thank you, ma'am.
Thank you very much. I am glad to give an interesting session, and I hope it was a valuable session for you all. So again, if you have any questions, you can directly write to me, please.
Yes, thank you so much for your valuable time, ma'am. And I'm thankful on behalf of entire ABS family that you have given your precious time and share the wide knowledge. And the time was at morning from your side, so it was really, appreciating. And I'm highly thankful to you, ma'am. Uh, Thank you so much, ma'am.
Thank you.
All the participants, our next session will start at 11:30 by Dr. Goswami. And in afternoon, we have a valedictory session. So your presence is mandate from our side. And I request you all, please be there in the valedictory session too. So now we will go for a
Sure.
small break. Thank you.
Right. Thank you.
Sai, are you there? Would you like to share anything?